All right, today's lesson is using our previous knowledge of solving proportions and setting up proportions and looking at a ratio. We're going to apply that knowledge to word problems. So ratios, we can use ratios, can be used to solve real world situations. So I can use ratios. Ratios are very important because you use ratios to solve a lot of problems, especially when it comes to cooking. In cooking, you use ratios a lot. All right, let's look at number 1. Julia is planning to serve hors d'oeuvres. That's the fancy word, hors d'oeuvres. At her wedding, she plans on offering 8 hors d'oeuvres for every 3 people. If she has 250 people RSVP at the wedding, then how many hors d'oeuvres will she serve? Now, first of all, with this word problem, don't get bogged down on the fact that you can't say hors d'oeuvres or you don't even know what that word is. Because that word could be hamburgers, right? That has nothing to really do with the problem. I could have made that hamburgers. I could have made it hot dogs. I could have made it nachos, right? Okay, so we're going to break this question down by what I know, what I need to know, and then we're going to work through how to solve this. So let's look at the question. What is it that I know? I know that she has 8 hors d'oeuvres for every 3 people, right? That is something that I know. We know that she has 240 RSVPs. That is the information that we definitely know, correct? Yes? No? Okay. All right. So what is it that I need to know? That's when I look at my question. My question says, how many hors d'oeuvres will she serve? So I'm going to write that. How many hors d'oeuvres, if I can spell it right, will she serve? That takes that whole word problem and it breaks it down. Okay, I know that she's going to do 8 hors d'oeuvres for every 3 people. She's going to have 240 people there. She needs to know how many hors d'oeuvres she is going to be serving. All right, so here is where the big chunk of this is, our planning and our work. Okay, so remember yesterday when we talked about proportions and I told you that this part up here was very, very important? This is where it's going to come into handy. So the very first thing that I'm going to do when I plan this out is I'm going to do my fraction bar equals fraction bar equals fraction bar. That is the very first thing that I'm going to do. Now I'm going to go and I'm going to use my labels. So what 2 things, not numbers, but what 2 things am I comparing? Yes, sir.
Hors d'oeuvres and people.
Very good. Hors d'oeuvres. We'll just like this. Blah, blah, blah. That's what I do. When I don't have the room, I just kind of sloppy it, do the rest of it. Hors d'oeuvres to people. That is what I'm comparing. Would y'all agree? Hors d'oeuvres to people. Now, why these labels are so important. And this is the very, very, very essence of this. So really, really pay attention. These labels are so important because now everything that I'm doing with this top is all going to be dealing with hors d'oeuvres. So whatever number I put here and here has to be hors d'oeuvres. Everything that I'm going to put on the bottom deals with people. Okay? And so by labeling it, I can make sure I put my numbers all in the correct spot. So now the next part of my proportion, I have my labels. Now I'm going to put down what I know. Usually that is my rate or my ratio. I know that there's 8 hors d'oeuvres for every 3 people. So where would I put my 8 at? The top or the bottom? Yes, ma'am.
The top.
Why on the top?
Because that's how many orders. Yeah.
Because it's dealing with hors d'oeuvres, right? And then the 3 is going to go on the bottom because it's dealing with people. Everybody with me so far? All right. But I need to know how many hors d'oeuvres I'm going to be needing for 240 people. Where is that 240 going to go? On the bottom. Very good. Because it's dealing with people. Will it always go on the bottom? No. Because it just depends. What am I dealing with? Am I dealing with people or am I dealing with hors d'oeuvres? When we don't know, because we don't know how many hors d'oeuvres we're going to need, what do we put in the place of an unknown number? Yes, ma'am. An X, but you're right, but what is that vocabulary word? Starts with a V. Talked about it yesterday. Yes, sir. A variable. You're right. I'm going to put X, but I wanted to know that vocabulary word. So that would be a variable. For mine, I'm going to put X. Now I have just set up a proportion, correct? I've got my labels, what I know, what I need to know. Does everybody see that? Now I can use my strategies that we talked about yesterday in order to solve these. Okay, we can use our cross products or we can use that other strategy. Because I want you to get in the habit of using the cross products, that's what we're going to use. So we're going to do 8 times 240. Notice I'm not trying to do this in my head. I'm writing this out. No, that is not right. $19.20, is that what y'all got?
Yes.
Okay, good. Whew. And then what do I do?
Divide by 3.
Divide by 3. And I got 64, right? Does everybody agree with my answer of 64? Why not, Wyatt?
Because you didn't bring the 0 down.
Because I didn't bring my 0 down. I was waiting to see if anybody was going to do that. So how many times can 3 go into 0? 0. So X is equal to what? 640? Is that a reasonable answer? Is it reasonable that I'm going to have 640 hors d'oeuvres if I have 240 people? Yeah, that's a reasonable answer, right? So my solution is 640 hors d'oeuvres. Everybody see that? Does everybody get setting these proportions up? Because on your work that you're going to be doing today, you must set up your proportion for every single problem. I want to see your labels. I want to be able to see what you know and what you need to know. I want to be able to see that for every one of your problems. Okay, let's look at another example. Miss Hernandez was helping her students with their classroom economy bank accounts. The sum of the student with the most money and the student with the least money was $160. The ratio of the amount of the student with the most money to the student with the least money was 4-1. How much money do each of the students have in their bank accounts? Wowzer, that's a lot of information, right? Lots of information. So let's try to pick out what we really need. All right, so we don't really need this first sentence. We don't care about that. The sum, that's important, right? Sum means what? Say that again. Addition of the student with the most and the least is 160. So I'm going to write this, when I write it in the I know, I don't have to write it word for word because I want to be able to glance at the what I know part and easily. So I know it's going to be most plus least is going to give me 160. Is that still saying the same thing? That the sum of the student with the most money and the student with the least money is 160. Most money plus least money is 160. Makes it a little bit just shorten that, right? Okay. We know that the ratio of most money to least money was 4-to-1. So that's important information. So most to least was equal to 4-to-1. Right? Isn't that what they told us? Okay. Now, what is it that I need to know in this problem? I need to know how much money do each student have? So should I have one answer or should I have two answers? Two. The student with the most money and the student with the least money, correct? So I'm going to write that over here just so that I don't most, least. Okay. I have to just remember that. So I remember that I have to have two answers. Yes?
Would it be how much money does a student have?
Yeah, you can put that. It's fine. That's why I'm a math teacher. Okay, so now let's go ahead and start thinking about how I'm going to solve this. So I've deciphered what I know, what I need to know, and I've deciphered that I need to have two answers. But now let's figure out how we're going to come up with that answer. Okay, so here I know that the most plus the least is 160, okay? And I know that my ratio from the most and the least is 4. So I got to know what my total is. So when I'm writing my proportion out here, my labels are going to be, I need to focus on just one student, either the most student or the least student. Me, myself, I focused on the most when I solved this. So I've got student with the most. I'm comparing the student with the most to the total. And I use total because that is information that they gave me. They gave me the total was 160, yes? So therefore I know I have to use total in my words. Okay, so now let's go ahead and work through what I know. How much, remember everything on the top is dealing with the most. Everything on the bottom is dealing with the least. With the total. How much was the most? What is my ratio? 4. Now listen very carefully to this next question. What is my total? Dane?
160.
No, we're not there yet. We're not there because right now we're just working with the information that I know. We're going to get to that where that 160 is going to go in just a minute. But if I'm dealing with the 4, so remember it's most plus least, right? Gives me total. Most plus least gives me total. What is it going to be? 5, because I did 4 plus 1 gave me 5, correct? So my total in my ratio is 5. Really, really, really important that had I not recognized that I had to use total, a lot of students just say, oh, it's 4-to-1, and then put the 160 somewhere. Have to read these questions. All right, now let's go with what I know, what I need to know. So I need to know what my most student is out of my total. What is this 160? Is it most or is it total? Total, so is it going to go on the top or the bottom? What's going to go on the top? X, because we don't know, correct? And now I'm going to solve. So 160. Did y'all get 640?
Mhm.
Okay. And then what do I do? Did y'all get 128?
Yep.
All right. Is that for my most or for my least? My most. How do I come up with my least now? Yes, sir. I'm going to subtract. Tell me what I'm subtracting. All right. I know that total it's going to be 160. So if I take the 160 and subtract the 128, I'm going to get what? 32. That one had a little bit more problems to it, like several step, multi-step problem, yes? All right. Let's flip it over and continue working. All right, according to the 2010 census, the state of Oregon has a population of 40 people per square mile. If a county in Oregon measured 75 miles by 30 miles, then what is the expected population of the country? All right, let's talk about what we know, and then we'll move on. I know that it has 40 people per square mile. I know that it's measured 75 miles by 30 miles. And I need to know the expected population of the county. All right. Okay. Moving on. Let's talk about my work. I know Miss Armstrong's telling me I've got to start with this. My fraction bar equals fraction bar equals fraction bar. So let's go ahead. What two things am I going to be comparing? Look at the rate that they gave me. I need to know the population. So somewhere in there I need to have population, right? So population, right? Doesn't really matter. Doesn't matter if I put population on the top or on the bottom, because ultimately I'm still going to be doing the same thing. And then what else am I comparing? Square miles, right? All right, with me so far?
Yep.
Okay. All right, now let's go ahead and start figuring out what I know. I know for a fact that there is 40 people per square mile, right? That's the rate that they gave me. They told me that. Okay, now I've got to figure out what I need to know. I need to know the population. So where is X going to go? It's going to go on top or on bottom?
Bottom.
On the bottom, because I'm trying to find the population, correct?
Mhm.
Now I have to figure out what is the square miles. How can I find out the square miles of Oregon? Go for it.
I think 75 times 30.
Very good, because I need to find the area of Oregon. So in order to find the area of Oregon, I am going to do 75 times 30. And I am going to get 2,250, correct? So where is that 2,250 gonna go?
Top.
On the top. Now I have my proportions set up. Can I solve that? Yes. Okay, we're gonna come back to that because I want to be able to go over number 4 and at least the setting up process, and then I'm going to have you solve those, okay? All right, so I don't want to see anybody working on number 3 right now. We have it set up, and that's all we're going to do right now. All right, number 4. Jenna and Becca were both selling cookies door to door. Jenna sold 8 boxes of cookies for every 3 boxes of cookies Becca sold. Combined, they sold a total of 385 boxes of cookies. How many boxes did each girl sell? All right, let's write down what we know. We know that Jenna sold 8 to Becca's 3. Combined total is 385. What I need to know? I need to know how many boxes did each girl sell. So will my answer have 1 or 2 answers? 2. I'm going to have Jenna's and I'm going to have Becca's. Right? All right. So now let's start talking about how we're going to set this up. I know I'm going to have to do my fraction bar equals fraction bar equals fraction bar. I know that. All right. Okay. Okay, so now I have to decide what 2 things do I need to find out, what 2 things do I need to know in order to find out how many boxes did each girl sell. Well, I know I need to find each girl, so I'm going to choose a girl. For mine, I used Jenna. Does it matter if I use Jenna or Becca? No. And then Jenna, I'm going to compare the number that one girl sold to what?
Total.
To the total. All right, so now let's look at the information that I was given. I was given Jenna sold 8, right? To what is the total? Yes? 11, because 8 plus 3 is 11. Would y'all agree? So far, so good? Now, what I need to know. I need to know the amount that Jenna does. That's what I need to know out of the 385. Would you agree? All right. And then do I know how to solve this? Yes. All right. So that's what I want you to do is right now we've set both of these up and I want you to actually answer those 2. Okay?